Hello everyone, welcome back to another lecture of digital electronics series. In this lecture, we will learn about types of adders and we will study briefly about one type of the adder. So in previous lectures, we have learned that adders are half adders and full adders. So in this video, we will learn about mode of adders based upon mode of operation, and we will use full adders for this. So basically, there are two types of adders. One is serial adder and another is parallel adder. There is another type of adder which is less important, that is look ahead carry adder. So in this video we will learn about serial adder, and in next video we will learn about parallel adder. And now let us take a 4-bit number. Let us say I am having two input variables, let's say A3, A2, A1, A0, each of 4-bit, and here B3, B2, B1 and B0. So I need to perform addition between A and B, which are of 4-bit. So what I will do is, here initially my carry will be 0. So here A0, B0 and my output produced will be S0. And let us take my sum output is 0 and let us say it is producing some carry C0. Then my this one will be S1, my sum, and again this will produce some carry, let us say that one as C1, and A plus B plus C1 will produce some S2 and will produce some carry C2, and it will produce some S3 and it will produce some carry C3, which we will write this one. So when we perform addition between A and B of 4 bits, then we will get this C3, S3, S2, S1, S0 as output. Now let us understand how this serial adder works. So let us say I'm taking one full adder. So I will add one bit each bit by bit. So here let us take, I will take A and here I will take B, and this will be my CL and this will be my sum and this will be my carry output. So now let us perform bit by bit operation here. So let us, initially I am taking A0, B0 and initially my Cin is 0. So this will produce some output, sum, that is S0, and this will be stored in one register. And simultaneously it will also produce some output, some carry output, that is we are considering here as C0. Similarly, when I perform between second bit A1 and B1, A1 and when I am feeding this as input to the full adder, and here I am also considering, I am taking this C0. So I will perform this one and I will get my sum S1. So again this will be stored in another register and it will produce some carry C1. Similarly, I will do for A2, B2, and here it will be C1 and this will produce some output S2 and this will be stored in another register, and another carry output C2 will be performed. C2 will get as output, and then next one will be A3, B3, and I will do addition between A3 and B3, and here my previous bit carry, that is C3, sorry C2. I'm taking C2 here, and this will produce my output C3. So my output will be C3. This will produce S3, right? And this will show in one register. S3, C3, S3, S2, S1, and S0. So here this is my output for serial when I am performing addition serially for a 4-bit operation. So what we can draw from this is, so in a serial adder we are using only one full adder, and it will perform for performing n-bit numbers, addition of n-bit numbers. So the result of each bit will be stored in a register. So that is what we saw here, and here the delay is very high because first I am adding first bit A0 B0, and then after completion of this operation I am going for A1 B1. Let us say that for completing this operation I am taking time Ts. So let us say that sampling time as Ts. So this is my foliar is taking this much time to perform the action. Similarly, for this one it will take another Ts, and this will do and we will do for B1 B2. And after taking another Ts of time, my operation will be done between A3 and B3. So when we consider this one, so here we are having 3 Ts. This much delay we are getting added. So while performing addition using serial adder, our delay is very high. So that is the operation of serial adder. So we will complete this in this video here, and in next video we will learn about parallel adder, which is most important, and this is only used. Serial adder we will not use mainly, but parallel adder is widely used because it is very fast. So we will learn about parallel adder in next video, and after that we will understand the sum and carry delay operation with some examples, and then we will do some PYQs. So